For a practical example about the difference between problems and improvements in basically the same topic, let's check out 2 ways to reduce cleaning time. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video, it is a viewer request on could you please show sort of a practical example on what is that difference between improving and solving a problem, and why is there a difference? And I know for many people also out there, the split that I make between problem and improvement is a split between 2 types of improvement. For different people, it is a split between 2 types of problem solving. So yes, indeed, it is a bit about how I put those things, but I think it is a good way for you to really distinguish when you are talking with people in your organization about improvement, about control, about performance. Talk about the difference between when are we solving a problem to get back to a standard and when are we trying to improve that standard, because that first thing is what many people also say is like a single cause event where we will problem solve, and it'll hopefully take us something like 2 to 3 days, maybe weeks if it's a bit more complex. While when we are really improving our standards, we are sort of redesigning our processes, and very often that'll take a lot more time because we are not going back to a known standard, but we are going to increase, improve, redesign the standard by checking all kinds of process metrics. But okay, let's then go into this with an example of cleaning time. So we've got our cleaning in place time, and we have been performing this cleaning nicely, just under the norm for quite some time, and then suddenly we hit a number of very long cleaning times in a row. Now that is a very typical problem where we deviate from the standard. So we had the standard. You do see that we were usually able to perform slightly better than the standard. I will also say if one of these was slightly over the standard, we would have colored it red as well. We probably would have seen it as a minor incident and not immediately jumped at it, but it's a bit on the other problems we have in the factory. So I chose to just have this quick shift, and we sort of sustain this new problematic level. Now that is where we get into problem solving with the idea of getting into root cause problem solving. See, here, and specifically there, we think that a single event caused this shift. It may very well be that several causes needed to be lined up, so to sort of overcome the backup system, so to say. So a couple of things needed to have happened, but here it just tipped. The bad things fell together, and we now have a different situation with a lot worse performance. And because we are seeing a single event, we actually also expect there to be a root cause, and that is the big difference. Now, as I said, maybe we've got 2 or 3 root causes that sort of all broke at different stages, but in the end, one thing actually broke through at that moment. And if we find it and fix it, we can assume that we get back to our normal performance levels. Now, to analyze this, we want to analyze that root cause and then find it, right? So first we need to know what triggered that, and then we need to also find out what was the root cause of that. So we fix the direct cause and we look for the root cause to make sure it doesn't happen again. Basic continuous improvement practice, right? We go from a fishbone to be broad in finding what was the event that triggered it, what was the direct physical cause. Do remember the fishbone isn't really used to find root causes. The fishbone is a brainstorming tool that you can use to really get your team to pick at different categories and not miss the maybe not directly obvious causes. it will also keep you open to this idea that from time to time this single event needed one or two other trigger points to also go away before it could have the effect on performance. So one, maybe two of those causes that we see, those top level causes, we dive deep and we do this 5 why analysis to get to the root cause. Got videos on that, got also loads of material all around on the internet on this. So you are used to these things, but this is all problem solving. We think that there is a problem caused by a single event, so we expect a single root cause and we analyze, find and eliminate it. Now, what if we want to do an improvement? Because some people will say getting rid of that is also an improvement, but here I take a stricter line, and that is, it is only an improvement if we can go under this standard. So to ignore the red ones for now, what if we say we want to improve this performance? So we take our normal performance, there is some variation, that's already interesting because it means that from time to time it goes better, so there are sources of variation that we might be able to tackle, but in general we know that this is the level we can always reach, and we're going to check out what is happening underneath. We're going to analyze the process, and there is the big difference. This will usually not be a 2 to 3 day or maybe 2 week project, but more a couple of weeks to 3 months project. And let's say that when we analyze our cleaning schedule, we try to find options for improving it. I'll draw out an example where we do find some options, but then we get into the reason why this will take longer. So we have this process of cleaning different strings on our machine, and the strings A, B and C, they all have their objects that they need to clean, and we have a cleaning, and then we need to sort of reset and reset all the valves to make sure we can clean the other stuff. So every time we have to wait until the cleaning of the objects is finished, then we move on to next steps. We need to make sure that they are finished and move on to next steps. Like this, we make a cleaning program where, of course, this is a sort of a simplified, or at least an example with a lot of potential. We see that there are different blocks that maybe if we can move them around, we can shorten the total cleaning time. So basically, by putting them in slightly different order, we take away those inbuilt problems, those obstacles in being faster. We take waiting times and we see, can we do something with those waiting times? And we condense them into a program that is quicker. So that really is process redesign, and it takes different skills. Because when we redesign a process like this, maybe this doesn't work. Actually, pretty likely it doesn't work like that. We'll have to test it. We'll have to see what are optimal settings, and very important as well, we have to validate such a process. What are optimal settings? And very important as well, we have to validate such a process. And the funny thing is that testing and validating, that actually uses that same fishbone. But we don't go into the 5 why. Because what we're doing here is we're not looking for a root cause of why it went wrong. We are looking at what are the most optimal process settings. Can we move this object do the first series of things to be washed? Or is it not possible at all? I mean, maybe some of these objects flush through that object when cleaning. So if we clean this one first, we'll have to clean it again anyway. Maybe, right? Just the example here of a cleaning system, but you can imagine that not everything here works. And the same goes for when we're dealing with a sealing unit, where you know that maybe by increasing the pressure you can decrease the time a little bit, but then do you also have to do something with the heat or with the plastic itself that is the material for your seal, all kinds of things like that, where you have a number of factors that influence each other. And what you're trying to do is to make the process faster or cheaper or in any other way more optimized, but you are changing it from the standard, because this whole length of time, that was the dotted line, that is the norm over here. So we are trying to decrease the total time it takes, but for that we need to do a lot more checking and validating of our process, and also know that this will not run into new problems later on the road. And that's why when we are talking about, we are going over cleaning times, we want to do something about cleaning times, what you can do is you can focus on, and this is especially true in the beginning, if you usually hit your targets, but sometimes you're just over for maybe only one shift or a couple of cleanings in a row, and then it goes back to normal. Then a bit later you go over again. You get into this gray zone. Is this still problem solving, or is this already an improvement project? Because it's not really a single event, but so if we would just drop the line a little bit, it would be red, 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 a couple of reds. So are these linked to a root cause or to an improvement thingy? We don't really know just by looking at the data. And that is one of the things you need to find out quickly. But that's also one of the reasons why in your performance control system, you need to be looking at your performance in an objective way, saying the standard is not what our manager would like the cleaning time to be. The standard that we can at this moment perform to is what we see in the past, right? So what have we been doing for the past number of months? Did we always have about a 40-minute cleaning time, even though the textbook standard was 30? We can call all of them problems, but it just means that we have a standard that is a bit higher. Apparently, we never were able to do it much faster. And if you say, well, but there's one guy who did it in 30 minutes last week, that doesn't make it a standard yet. That means that there is probably some potential here. It might also be that that guy last week skipped an important step that if you would do it every day would cause problems. So then we are looking at an improvement project, right? We are going to reduce the amount of resources, the cleaning time in this case, and we really want to do that through process redesign. For that, you also really want to check settings lists. You want to check your basic conditions. Do we need to upgrade our maintenance? Can be part of this. I mean, poor maintenance could be the root cause for a breakdown in the system that happened over here. So the same answers sort of might come out, but we are not looking for that root cause. We are looking for what are all the things we need to do to improve this process. So we will fishbone, we will go to settings lists, we will really dive deep into how the process works, and that'll take a lot more time. And that is why I call that an improvement project. Same CI skill set, same end goal, better performance for the factory, but a different mindset and some different expectations on resources and time. Those expectations are very important. Now, then there is the other thing, why you want to be talking about problems in my more narrow definition, and that is that we are always trying to improve our processes. And if we launch teams that improve the processes, but then don't give us a really nicely updated standard with a good way to check it, and then that team moves on to the next problem, the next improvement, they're not going to keep those gains, right? You need a good system of having a standard and then checking when there is a sudden problem with it and fixing that, because that is the best way to make sure that those more expensive improvement projects do keep giving their result, sustaining the changes, the results that you got from previous improvement projects. Needs a good system of controlling your performance and calling it a problem when you suddenly go over an established standard. So that's how I see it in cleaning times. Industry example, I've done a whole bunch of both of these projects. It's very similar in all kinds of breakdown things, cutting, material waste. I thought this was one of the clearer ones to share with you. I hope you liked that example and have a better understanding now of why I differentiate between those problems and improvements. If you did, don't forget to hit that like button. Also, ask your questions down below. And you know that I've got a whole course on problem solving, right? Finding that root cause, doing that with a team that is much more focused on getting your team to fully cooperate and put their minds together than most of the other problem solving courses out there. Because I am 100% certain that if you can get your team to work together with basic problem solving tools, you will have a much better result than when you have one or two people highly trained but not that broad scope in your team. Anyway, I wish you the best of luck with both your problems and your improvements, and always remember to also enjoy the continuous improvement journey.